Hello friends, hope you're doing well. Welcome to the session on Introduction to State Space Analysis. We already know a common or general control system where there is a plant which is controlled using the controller. This can be any system which is controlled by a controller. A reference input is given to the controller and it sends actuating signal to the plant and we get the controlled output. Due to some disturbances or any other means, if we don't get the controlled output, so it is given back to the system using feedback system. It is a feedback output of the feedback system is compared with the reference input, and depending upon that, a further control action is generated, and hence for the system works according to our desire. There are two methods of design and analysis of a feedback control system. One is known as classical approach and the other one is known as state space approach. In classical or conventional control theory, whatever system is defined is transformed into a transfer function using any transform method. It is basically applied to single input, single output system, whereas state space approach is basically designed for multiple input and multiple output system, where we try to represent the system in terms of matrices. Classical approach is basically frequency domain approach where the mathematical tools like Laplace transform or any other transform are applied. So a given system is transformed into frequency domain transfer function. Computation and analysis is done in frequency domain itself, and finally the obtained result is converted back to time domain using inverse transforms. The advantage of classical approach is that it provides stability and transient response very fast, whereas it has several disadvantages also, just like it can only be applied to linear and time invariant systems. It does not account any initial conditions. We don't get any idea about the internal state of the systems. It cannot be applied to multiple input and multiple output system. And it's very difficult to use the classical approach using computers. Having known these limitations of classical approach, can we think of the need of state space approach? So here is your question. What is the need of state space approach representation for analysis and design of a system? Try to think. Alright, obviously those drawbacks which are there with conventional approach are overcome by state space approach. In addition, state space approach is represented in terms of matrices instead of single system equation, and that's why it is very easy to implement this with multiple input and multiple output system. It can also be applied to nonlinear and time variant system as well. It can handle the systems with non-zero initial conditions, and due to its mathematical compatibility it can be easily implemented with the help of computers, which is much more suitable for modern control system. It also gives the idea of internal state of the system. Formally, state space representation is defined as a mathematical model of a physical system as a set of input, output and state variables related by first order differential equations. We'll try to get more about this further. There are some terminologies in state space analysis which we should know. The first one is state. It refers to smallest set of variables whose knowledge at time t is equal to t0, where t0 is the time when the system is at rest or before the system is switched on. So it refers to the smallest set of variables whose knowledge at time t is equal to t0 together with the knowledge of input for time t greater than equal to 0 gives the complete knowledge of the behavior of the system at time t greater than or equal to 0. State variable. It refers to the smallest set of variables which helps us to determine the state of the dynamic system. State variables are defined by x1 of t, x2 of t, xn of t. Please note these are the small x1, x2 and xn. State vector. State vector is a vector whose elements are state variables. So if we try to combine these three definitions together, it goes like there is a state vector whose elements are state variables like x1, x2, xn and so on, and if we know the value of these state variables with the help of the values of input, we can get the behavior of the system at any time. So this is how we can combine these three together. There is something known as state space. It refers to an n-dimensional space which has its axis is the state variables. So in state space system is represented like it has input variables, there are state variables, and we have the set of output variables. Let's try to understand the significance of all these three quantities further. A state variable is the smallest possible subset of system variables that can represent the entire state of the system at any given time. Please try to understand the term time over here. The state variables represent values of inside the system that can change over time. By taking an example, in an electrical circuit, current or voltage of energy storing elements are taken as state variable. Why? Because energy storing element, just like inductor or capacitor in electrical circuit, stores either current or voltage, and they are dependent on time. And state variable is represented by small x of t. The input variable is a vector which is a set of all the inputs to the system, and output variable is another vector which is set of all the inputs to the system. Output variable is combination of input variable and state variable. So a state space equation or state model is a combination of state equation and output equation. Together, state equation and output equation is known as state space equation or state model. Let's try to understand these state equations. So we can see over here a state equation which is first order derivative or first order equation which is a function of time t is equal to 0 and any time, and then state variable at time t is equal to 0 and input vector. Whereas output equation is the function of time t, state variable and input variable. In matrix form, state equation and output equation are represented as x dot, which is first order derivative of x. X dot t is equal to a multiplied with x of t plus b multiplied with u of t, and output equation is given as y of t is equal to c multiplied with x of t plus d multiplied with u of t. In matrix form or vector form, these state model is defined as given over here. One thing we should understand over here is we must know the dimension of all the vectors like x, x dot, u and y, and all the matrices which are a, b, c and d. We'll try to understand the significance of all these matrices also. Whereas matrix A is the system matrix and relates how the current state affects the state chain x of x dot t. Matrix B is the control matrix and it determines how the system input affects the state chain. Matrix C is the output matrix and determines the relationship between the state of the system and system output. Matrix D is the transmission matrix and shows how the system input affects the system output directly. We must understand it is very rare that input is directly transmitted to the output, and that is why the value of matrix D is mostly 0 in most of the practical systems. A state diagram is a diagram represented in terms of state variable, input variable, output variable, and the matrices A, B, and C and D. We can see x dot t state equation is combination of A multiplied with x plus B multiplied with u, whereas output y is combination of c multiplied with x and plus d multiplied with u. We must understand the dimension of all the vectors and matrices properly. So how to approach to represent any system in terms of state space? So we must select a particular subset of all the possible system variables and call it a state variable. Then we need to form first order differential equation in terms of the state variable. We call these system of simultaneous differential equation as state equation. Algebraically combine the state variables with the system's input to get output equation. We arrange all the state equations and output equations in matrix form to represent the system as state model. Let's try to understand all these theory in terms of example. So for a given electrical circuit, we are supposed to represent this in terms of state model, where output is given as the current through the resistor. By knowledge of state model, we understand that we must know what is our input, what is our output variable, what is our state variable, and what are the different energy storing elements in order to represent in terms of state model. So let's observe this circuit over here and try to answer how many state variables are there in the circuit and also try to identify them. Alright, let's go ahead with the solution. By properly observing the circuit, we understand that state variables are the voltage across the capacitor and current through inductor. Why we say though? Because they are energy storing elements, and we have initially mentioned current and voltages with respect to energy storing elements are taken as state variable. Our input variable is voltage applied to the circuit, and output variable is given in the problem statement as current through the resistor. Because we know we have only one input, one output, and two state variables, so the form of state variable we have will be like this. We have system matrix of form dimension 2 by 2, control matrix of dimension 2 by 1, and output matrix of dimension 1 by 2. We'll identify over here our state variable 1, x1 is Vc, x2 is IL, input variable is V of t, and output variable is IR of t. So on given electrical circuit, we apply basic principles of electrical systems like KVL and KCL when we write current equation and voltage equation. By the help of these two system equations, we try to rearrange the equation of KVL and KCL, and finally we arrange them in terms of state equation. Similarly, we also identify our output variable and we try to write the equation of output equation as well. Once we rearrange all the state equation and output equation in terms of our state model, then we get our output, final output is mentioned over here. So we can see state vector, state equation vector, this is system matrix, this is state vector, this is our out control matrix, this is our input vector, this is our output vector, this is our output matrix, and this again we have seen over here, it is our state vector. So we try to understand all the concept related with state space representation, although it is very fast to cover all those things, but I am going to provide the PPT of this presentation as well, so no need to worry about it. This presentation covers all the concept in details for basically the understanding of the basics of or fundamentals of state space representations. We'll try to understand its application and its further significance in analysis and design of a system further. Till then, thank you.